I'd like to introduce our next panel. So we have Chris Brooks, Assistant Professor, School of Information at University of Michigan. Hey, Chris. Huang, Lab Manager at Harvard Business School. Jim Stigler, Professor of Psychology at UCLA and a core member of CourseKata, a platform for delivering innovative and data-driven curriculum for teachers and students of statistics and data science. And lastly, but not leastly, Eric Van Dusen, Outreach Lead at the Data Science Undergraduate Studies, UC Berkeley. Eric also leads a team of developers of cross-disciplinary open source data science curriculum. Maybe Eric, maybe I will start with you if that's okay. And let's just talk about how notebooks are transforming how we teach and learn.
So yeah, I have just a few slides to think about how teaching with Jupyter is changing how we teach overall, like basically changing a whole stack of teaching and thinking of Jupyter as having a whole stack of technology in it, making Jupyter books, making packages specific to a class, doing the auto grading for the class, making modules in all sorts of classes, and sort of scaling this. So at UC Berkeley, we have very large implementations of JupiterHub. We have a Data 8 class with 1,400 students in it, Data 100 class with 1,200 students in it. So we have these huge JupiterHubs that are built out for each individual class, but we also have one that goes across the whole campus. So the giant classes have their own hub, but then we're able to also build these classes like a sociology class, an economics class, a cognitive science class that connect out to disciplines. We also do these modules so we can go into biology 1B, 700-person intro biology class. It's not a data science class, but we can put a couple Jupyter modules in there and teach in this way. We can also do this at the upper division, like advanced econometrics. They want to do some important case control study. They can really easily deploy RStudio in their class through our JupiterHub. We also have people who build entire classes based on Jupyter notebooks at different levels, some advanced classes, some basic classes. Jupyter books, once you're making materials in Jupyter notebooks, it's really easy to make your lecture notebooks into a textbook. If you check out the Data 8 textbook, the textbook from my class, an economics class, taking a set of Jupyter notebooks, bam, command line, it turns it into an open source textbook that can evolve every semester. A couple other things are making packages that are specific to each classes. So two of our biggest classes, Data 8 and Prob 140, have a specific Python package. Pip install, data science, there you go. You have a simplified, reduced set of commands. The beginner students not in pandas, they're in like some simple commands. Other thing that we're working on big is how to grade in notebooks and how to scale this. So this AutoGrader project is compatible with Deepnote. It's a little fiddly. It's not like AutoGrader is the easiest thing in the world, but it is pip install otter. It is a way to do assessment, to do feedback to students, and we're scaling this. This is what's running in 1,000-person classes right now. This is a little out of date. Otter 3.0 is out right now. It's also being taught in some pretty big R-based classes as well. It's open source projects. We need your help. Please contribute if you're interested. So what has happened? So we have this big JupiterHub and we're able to get students involved in a huge range of different classes. We've had over 55 classes with data science modules in them. We've built over 35 different connector courses over the years. And we have students helping to build Jupyter-based curriculum for other classes. Just really quickly, we have a library of notebooks to share. If you're interested, international development, sports analytics, there's stuff out there in all sorts of different, and this is what's so great about being an open source project. Build notebooks, put them out there, other people can share them. The connector courses, this is what I do. I teach a class that's between data science and economics. So we're teaching like fundamental principles of economics, but let's teach it in Jupyter, give students data sets to think about every demand curve, supply curve, macroeconomics. I also do a lot of stuff of outreach. Deepnote was at our workshop last year. We have instructors from around the world that we partner with in sharing curriculum. There's a lot of documentation. If you come by our website, you can sort of like learn a lot about what a a new instructor might want to learn about getting started in teaching with Jupyter. So what I want to say is Jupyter Notebooks and being able to be close to this project, the way that Data 8 was built was sort of as a core open source project. And that meant, you know, not just the curriculum, it's not just the textbook, it's like so many parts of this stack are open source. And that's what's allowed it to have a big impact globally, nationally. We're teaching with a set of community colleges right now and articulating so people can take a Data 8 at community college and come to UC Berkeley. There's all these elements that allow like multiple people to contribute, multiple people to feel confident using it, like they know they can adapt and change it. So I don't want to go on too long, but I just want to say, you know, there's many aspects of this. I guess our hook to Deepnote right now is I use Deepnote for our development team. So when I'm developing new materials with students, I love working on a team, like collaborating on new materials before we launch them. So we can like build stuff in Deepnote and then launch it onto our main JupiterHub. And I'm also interested in Deepnote for education for sort of the longer tail. There's, you know, lots of places that aren't UC Berkeley that want to teach with Jupyter. And I think it's a great option for people new to the platform to just jump on and be able to teach, you know, without a big startup cost.
So basically, I was a part of the teaching team on people analytics for Harvard Business School with Jeff, who was on here earlier. And we really enjoyed our experience with Deepnote in terms of using like the notebook functions. What happened with us was that before all of this, we were trying to use like Google Colab, and then like the laptop would just crash consistently, or like the notebook would just crash, or like, you know, 10 minutes later you install and you're still not sure if everything's all done and everything. So basically how we used Deepnote was we would have like two teams. We'd have a teacher team where like the 5 of us instructors would collaborate and go crazy and panic at the last minute if the notebook wasn't correct, and we'd fix everything. And then once we fix it, we publish it to the student team where all the students could go look at it at once and then personally copy it to their own laptop. So we found that like this process was much easier than like all the other previous platforms that we were attempting to try. And I think the other thing that I really want to say is that I find like this platform to be super accessible, because when I was in undergrad at the University of Michigan School of Information, I had a Windows 7 laptop and I was attempting to do data science, and it was this horrendous chaos fire. And every time I walked into office hours, my professor would not be happy because the problems were like the computer is just not running this code. And I just find that with Deepnote, it's just so much easier to just have things up and running and do the exercises as a student. So yeah.
Can I follow up there and just keep a Michigan School of Information theme going? So, you know, Berkeley's Data 8 is amazing, right? This is like inspiring and awesome, I think, and really is, nobody, I think, comes close to this as a program. The scope of and the impact that can happen. One of the challenges we have with something like this is it requires DevOps. It requires infrastructure, whether it's virtual or whether it's physical. It requires people to run JupiterHub. So here at the University of Michigan, we launched an online master's degree. We've got something like 800 students in it. Every single one of our courses is Python-based. Every single one of them is taught inside of Jupyter, or all the technical courses are. It's hosted on the Coursera platform. It uses that kind of Coursera DevOps area. And it's tough to do that. And when students are done the course, they want to keep learning. They want to keep working. And that's where Deepnote has really been a shining star for us, is in deploying things outside of our regular course infrastructure and into co-curricular activities or into continuing education activities for the students. So for instance, I ran a Saturday Twitch group with students where we just got together for 2, 3, depended on our interest, hours, and opened up a shared Deepnote and just worked together. And the collaboration features were amazing. I mean, this is just a totally different way to explore data science and learn data science, when you can actually change things, try things, clobber somebody else's code, and then use it as a teachable moment to say, do you know why that happened? Because the interpreter we're using is blah. Where you can start to dive into, like, how does a Docker file work, and start to kind of roll that out, especially for students who aren't CS majors, and so who don't have a solid understanding of what a container is, what a virtual machine is, what a physical machine is. I mean, in truth, lots of CS majors don't have that deep understanding either, and we can kind of layer in the pedagogy through those co-curriculars. And that's really been, for me, absolutely amazing with Deepnote. And then a lot of the students then went off and self-organized around the use of this platform, especially for group work. And in our program, it is for applied data scientists. It is not for CS. We're an I school, so we're not a stat school. We're not an engineering school. And so, you know, sometimes some of our students even coming in, you know, are challenged with GitHub. I mean, lots of people are challenged with GitHub. We just don't want to admit it because it's so core and fundamental in computer science. And so collaborating in this way feels natural and is really, to me, one of the most brilliant pieces, along with the fact that it's a hosted open platform that is freely available platform.
When do we need to go by?
Was that?
Okay.
Oh, yes. So that's kind of what we found in Deepnote, or what I found in Deepnote to be really powerful, to augment all the JupiterHub infrastructure that we've set up and we've invested in, which is similar to what Berkeley's got going.
I do have a general question. What do you think are the main advantages of notebooks versus scripts? Do you think that students can graduate from a notebook to other tools, or should they just stay in the notebook? Any thoughts on that?
I'm personally just totally into, like, it's a new way to teach. It's a new way to think. It's a new way to organize your thoughts. I think it's its own world. I more have the other problem where, like, I have students that are more that are coming from scripts, and I'm like, no, you need to make this a rich document. You need to attend to your markdown and your explanations. I'm pushed the other way. I think, like, as curricular materials that boom turns into a book, turns into a website, turns into a visualization. I think it's like I more wanted people to go from scripts to notebooks. And then I guess, this is a tricky one. And the Deepnote is the IPy widgets aren't super working, or voila, or whatever. Like, but what I want to, I don't know, some dream world, I teach some other class that's like dashboarding and widget building and interactivity building. And I think that's an art, like you could go work for a company and you'll be like, how do I report this to my boss? Like, do I make a widget dashboard? Voila, something cool. And there's some of Deepnote that's doing that. I hope that it's not, like, it doesn't end up, I don't want this to end up being a forked thing. Like, I want this to be like, people are still learning general tools and not specific tools. But I think that for me personally, the notebook is the way to just sort of change your perspective on live documents. I mean, so we don't tell students really that much about reproducibility. I had one class where I was teaching students, I was like, look, everything you've learned in Data 8 is the core of reproducibility. Like, it's all run off GitHub and it's all like instantly reproducible between students. And like the tool of Jupyter was made for scientific replication, but it just so happens to work really well for teaching. And you're like, this message is a little, like, this opportunity is a little lost, that we're not telling the students that, like, someday this is how science will run, and someday this is how lab groups will communicate with each other.
One thing
I think is great about notebooks, and especially for teaching, is that it highlights the storytelling and narrative part of what we're doing. So you can have scripts, and we've all done this, and you just get lost in your own sea of thinking. But with a Jupyter notebook, you're telling a story. There's a beginning, a middle, and an end. You're explaining what you did, why you did it, even if the audience is just you, and what you learned from it, and then moving on to the next part. So I think it's really helpful to keep students engaged with thinking about what does the product look like of all this work that I'm doing, and they see themselves creating that product as they go. So I think that's a really exciting aspect of Jupyter, and obviously Deepnote, but notebooks in general.
I mean, data science, I think, is well taught through exploration and interrogating the interpreter as you go in the interpreter state. And Jupyter and Deepnote, these handle it very well, and scripts don't. With scripts, you insert a breakpoint and then you start your interrogation. And then when you step too far, whoops, okay, stop now, rerun it all back to your breakpoint. It's just a model that isn't great for that interrogation. There is this looming question about now, how do you take this notebook that you've created, this computational narrative, and how do you turn it into a production task that's going to run regularly? And there's some solutions that are out there for that, and places like Netflix have been doing pieces with this. I'm not sure that's as robust, right? When you want to start doing unit tests and layering them on, it's not that you can't do this, it's that then the notebook paradigm doesn't feel quite as natural. And I think that there's still a lot of work to be done to tie the two paradigms together so that you can have that interrogation, but you can also refactor something out into a function that's going to be run with unit tests. So it's beautiful where we're headed, though. And I absolutely think that it's not an either or, it's when do you use which ones. And certainly for teaching, notebooks are just wonderful.
Wondering if anyone has any comments. This actually comes from Matt. Any comments on the advantages of JupiterHub versus Deepnote?
I have some. I've never been preempted in my own JupiterHub, right? So they're definitely, right, when you're relying on an external party versus relying on your internal, you have to kind of build that into your expectations. We also have the ability to kind of set up the environment in very specific ways. So, I mean, our JupiterHub is pretty integral to a lot of our inner workings. The downside, though, is the lack of collaboration. Now, with Jupyter 3.1, there's opportunities for collaboration. I was working with a team and the Cal Poly team over the summer to explore that and build things into that. But that's still not where Deepnote is right now. It's not a production system. It's not hooked up to JupiterHub, so it's within a Jupyter workspace and so forth. It's still growing. And I think that, to me, that's where Deepnote really shines. Deepnote's got a lot of nice features that don't break the computational narrative model. Things like having sparklines in your data frames automatically, or basic vises in the data frames automatically. There are some, and I think that Eric made a really good point about this, about the forking and the question of compatibility. There are some that are harder, right? Like SQL blocks that then maybe tie into, I mean, I think this is wonderful, but I worry sometimes about teaching students something that is, I'll use the word vendor specific tool. And so seeing that kind of contribution back out would be nice. This, of course, is not unique to Deepnote, right? We also have the Google Colab, right? We've got SageMaker and SageMaker libraries, which are really wonderful if you want to do like a grid CV across many EC2 instances, but now you're tied to AWS. And of course, we're going into the, PyCharm does its own notebooks, VS Code does its notebooks. So I think it would almost make, I think, a lot of sense right now to start having some more, I don't want to say standardization, but shared conceptualization across all of the computational narrative supporting platforms to help all of us feel like this is a fruitful garden that grows together and isn't a competing in a negative way space.
there's a big controversy around notebooks enforcing bad coding practices. Now, I love notebooks. That's why I work at a notebook company. But there's some kind of valid concerns that the same reasons that notebooks are so great, which is kind of fast iteration, fast explorations, are the same reasons that software engineers kind of tend to abhor them, which is to kind of create reproducible code. Is this something you individually touch upon in your classes, or is this something that you kind of, for the sake of speed in a class, it's very hard to both teach why notebooks are great and both kind of teach data science and at the same time teach when not to use notebooks? It's a very, abstract kind of question. So is that something they have time to talk about in your individual courses, or is this something that you just hope that is kind of resolved later on in the student's education?
I don't know exactly how to answer that, but I guess for us, there's a lot of like style and pedagogy in the choices that are made in notebook design and how we teach. And there's a part where students aren't learning, how to make a structured script, but there's also a part where they're learning a lot about communicating with code and annotating code and breaking things into chunk, and functions are here and we'll call it. And then, they're learning this narrative approach, which is slightly different. Yeah. If you want to be a software engineer, you should go and take a few other classes, right? But I think I work with these teams that are sort of making curriculum for the next class and the next class, and like taking a new faculty member who hasn't taught with code or notebooks before and making notebooks for them. So what I love is like seeing that the students have internalized this and have a vision for how to make pedagogical materials based on basically like doing the 50 notebooks in data 8 and data 100. And then they're able to like, have a vision for how to do this for legal studies or biology or, so that's just sort of like this cool intersection. So I like that, but yeah, if you're going to write production code, you definitely need to take some other software classes that's not, notebook based.
Yeah, this is one of my favorite topics. Partly because I'm a brain imaging scientist, sort of by that's my sort of background, and I use code a lot in my research. And it seems to me that, and I've never had any software engineering training other than the kind of training you receive when you're contributing to an open source project. But I feel very uncomfortable with that sort of idea that there's this sort of distinction between a data scientist and a software engineer. It seems to me that my own work, I quite fluidly flip between the notebook, which is just an amazing breakthrough in sort of teaching technology, to my text editor and Python files, and I have to do that in order to keep thinking straight. So I don't think, for me, it really isn't, am I, a sort of, software engineer, or am I a scientist? I really want to persuade my colleagues that they actually have to learn to write code right in order to sort of use it. And that comes fairly early in your career. I don't do notebook off-ramp. I sort of tried, and it's just too much to teach in the classes that I do. So I completely understand not doing that. But on the other hand, I think being able to get out of the notebook and knowing when to get out of the notebook, and knowing that it is necessary to get out of the notebook in order to become proficient, which I strongly feel that's really important. I don't know how to do it, and I'd really like to know how to do it.
Given that notebooks have come so far, what are they still missing that you would need that would help you in your teaching?
I can think of lots of things. I could just start listing things off. So we're in Zoom. We don't have a notebook here that's synced between all of us. We should, right? We should have all of our RTC communication synced up. I use Jupyter sometimes in class with the Rise extension, and that allows us to build PowerPoint-like slides that are Jupyter slides. And so that's actually been useful in a classroom sense to focus people on specific pieces. We don't have permissions built into the RTC model, like we do in other kinds of like multi-user systems. So for instance, I can't make pieces that other people can't change, or that, I can't write some notes down and play with my own interpreter. I can't fork a live interpreter instance. There's lots of things I think that we could explore and play with in this space to that would have impacts on how we collaborate in education. And I think a lot of it comes down to also scale, right? And how we want to scale our like if we're teaching 1,000 people at once, if we're teaching, so I teach in a MOOC on Coursera as a platform, there's a lot of learners there. And sometimes I teach like 15 people, or my 6 PhD students. So I think that there's a lot of really interesting features, but some of it starts to be not features you would use in all of these different pedagogical environments, but where you would use it for small groups, where you would use it for co-located versus totally online, where you would use it for asynchronous versus synchronous places to go.
Yeah, there's also like super short-term stuff, like, like how to interact with the course management system, learning management systems, and like the LTI hooks and the like, like I'm like got this long tail of instructors that like, okay, use this JupiterHub, it's totally amazing, but figure out how to jump through a bunch of coding steps that aren't useful for them, and so the rest of the university is like, here's this implementation of Canvas that's like, all engineered. So that's like the beginners using it. So, there's people like at Lumidesk, there's other people that are engineering in this area of like, what's it like? I think we haven't heard enough from Jim Stigler, but, the CourseKata, like, what's it like to build the tools closer and closer so that other instructors can be using components of them? Is sort of where I'm at in interacting with the other parts of a professor workflow. We have a MOOC and edX, but like we have like our own built, JupiterHub on the side of that. And like, what is it like for the edXs and the Coursera's to have like an organic part of compute built into them? What is it like for Canvas to have an organic compute part built into it? So some steps of just making that integration closer.
I was just going to say, at CourseKata, we've built our own custom JupiterHub just because there's certain simple things that it's important to do, especially if you're teaching large classes like I do at UCLA. But for example, sometimes we use Jupyter notebooks for assessments. So we needed a simple way to distribute the notebooks to students and have them submit them back and keep track of when they did that. We also needed to have the ability to control cells, like if you put in the link to download a data set that the students are going to use for a test, and the students accidentally delete that cell, which happens all the time, by the way, then you got to make sure you have a way to either stop them from doing that or give them a way to easily refresh their notebook and get it back so that they can do their work. And then just another simple example is for grading. I don't teach computer science or data science students. I teach psychology students. And so I'm usually really just as interested in what they write in their notebook as the code that they produce. So we've just created a very simple tool that we can just take all the students' notebooks that have been submitted and take any cell that we've marked as a response cell and put it into a column in a CSV file so that as the instructor, I can then really quickly go through and grade students' responses. It's not auto-graded, but in fact, a lot of the stuff we look at, we can't really easily auto-grade anyway. So just things like that. We hesitate to push them too much because every instructor has their own workflow. But there are things, students will always surprise you with how they can mess up a notebook or anything actually in a high stakes sort of situation.
A little unrelated, but what we wish is that it would be easier to import our markdown into notebooks. Because right now, if you do that, you have to copy and paste, and sometimes it's a massive explosion, and it'd be easier to take our old R things and put them into the notebooks.
I have a question about data visualization. and how that relates to notebooks. Do you think interactivity and charts is a part of the reason why we're seeing this rise of data literacy, where people are becoming better scientists because the mechanisms are actually allowing them to get into their data a little bit further than they would have before?
Yeah, we've been working with Plotly and writing some wrappers, like even just like in our super intro class, maybe the Plotly is a little bit, has a few too many commands. So like what's a wrapper on a Plotly? So it's like call chart and it makes the Plotly chart and they can mouse around on it. I definitely know as well, you know, with Plotly, it was nice that I could save the plots as HTML and then put them in my Jupyter book as interactives. So there's fun stuff. For me, the one hard thing about visualizations is like, there's a bunch of stuff that's like evolving quickly. You know, Plotly is like also a little proprietary. So it's like Seaborn or Altaria, like as you mentioned, there's like which package to put throughout a set of course materials. Seems like every 6 months, like people are shifting around which package to use. But that's kind of the world I want to live in, where like innovation is happening and it's not like getting stuck on any one set of commands and in sort of like what's the outcome that we're looking for.
So just to, I'll amplify that and maybe contrast it with it, because the Python InfoVis space is the most frustrating to me because it's just crummy. There's so many different competing libraries. I mean, in my visual exploration of data course, I have an assignment, which is go find some library I've never heard of and teach me about it, because there will be a new one every year. I can count on it. And they can introduce me to whatever it is and its giant model for visualizations. And I find that actually really frustrating. And I'm not so convinced that there's innovation or versus just a whole bunch of like groups stumbling around, reproducing one another's pieces. And I do think that it comes in part because of this client-server model that the Jupyter notebooks or other computational narratives are built around, right? We don't have Python natively in the browser. And because of that, we always have to have this JavaScript to Python bridge. And for the students I teach, which are applied data scientists, they're not building software engineering skills. They're not going to like that. They want to build, let's say, a dashboard. I hate to use the word, but let's say a dashboard, but they're not married to a particular technology, but there's a huge cost to learning a new mental model. And I do think the BI world of things is moving much more coherently here, the Tableaus, the Power BIs, and that there's a real risk in the world of science that those will own the InfoVis world. Especially as they build out more robotic process automation, RPA, like Microsoft Flow and so forth. So they're able to do a lot more like go scrape this data, pipe it to an Azure web service, and then visualize the results and build all of these really fancy interactive graphics, which also happen to scale and install as a mobile app. So I think that that's like an area where I'm seeing more rapid progress versus just another toolkit that seems to also be able to build a bar chart. This one's got drop shadows, or this one's clickable, or this one's just a little different. I do think, and this kind of, I'll just do a callback to a comment I made, one potential place that could see this change is if WebAssembly really takes off. The idea of WebAssembly is that we can run essentially C code in the browser. It's kind of a lot of what the promise of things like ActiveX or Java applets or et cetera are. And you can, because Python's all written in C now, mostly you can then compile it into this browser module and actually run it in the browser. And this actually has the potential to deal with the issue of how do we deploy and host all of these server-side components everywhere? The answer is we don't. We just put it in the browser and can use that. But it also might help encourage a tighter bridge between the UX and the actual server-side implementation. And there are, with Pyodide, there's some demonstrations of this with Jupyter. I don't know anybody who's gone further than demonstration projects with it, but it's a pretty compelling perspective if it takes off.